Welcome back to What You Want to Get Which You Want. In today's video, we are diving into core principles and best practices that form the foundation of robust software architecture. Whether you are designing a small application or an enterprise system, these principles will help you build scalable, maintainable, and efficient system. Let's get started. Design principles are more than just guidelines. They are the building blocks that help you write clear, clean, reliable code. They ensure that your application remains flexible and can evolve over time without becoming a tangled mess. Think of these principles like the rule of the road for software design. Just as traffic laws keep your roads safe and efficient, design principles help developers navigate complex systems smoothly. Let's start with solid principles, a set of 5 guidelines that have become a cornerstone for object-oriented design. First one is single responsibility principle. Every module or class should have one and only one reason to change. For example, consider a customer management system. Instead of having one class handle both customer data and email notification, you would separate these into two classes. This makes each class easier to maintain and test. Next one is open closed principle. Software entities should be open for extension but closed for modification. Imagine a payment processing module. Instead of rewriting the code every time a new payment method is added, you can design the system to support new payment adapters without altering the existing code. List of substitution principle. Subtypes should be substitutable for their base types without altering the correctness of the program. If you have a general notification class, any subclass like email notification or SMS notification should work seamlessly in its place without causing error. Interface segregation principle. No client should be forced to depend on method it doesn't use. In a modular system, if you have a broad user action interface, it's better to break it down into smaller, more specific interfaces such as profile management and user messaging, so that classes only implement what they need. Dependency intervention principle. High-level modules should not depend on low modules. Both should depend on abstractions. In an e-commerce application, rather than having order processing modules directly call a payment gateway, it should depend on an abstraction like a payment processing interface. This makes it easy to swap out payments providers as needed. Beyond solid and other influential concept in modern architecture is domain-driven design or DDD. DDD focuses on moduling your software based on the core business domain. See their key concepts. It creates a common language between developers and business stakeholders. This ensures everyone is on the same page. Bounded context is it divides your system into different sections, each with its own domain model. This reduces complexity by keeping related concepts together. Aggregates. Define clusters of domain objects that should be treated as a single unit for data changes. Imagine you are building a ride-sharing app. With DDD, you have separate bounded context for ride management, payments, and user profiles. Each context would have its own language and rules, ensuring that the ride matching logic, for instance, doesn't get tangled with payment processing. Alongside these core principles, here are some additional best practices every software architect should consider. Don't repeat yourself. It eliminates duplication to reduce error and make code easier to maintain. Keep it simple, stupid. Simplicity should be a key goal in design. Avoid unnecessary complexity. You are gonna need it. Don't add functionality until it's necessary. This helps prevent bloated, over-engineered system. Separation of concerns. It ensures that different parts of your application handle distinct responsibilities, making the system modular and easier to manage. I'm giving you real world tips. In large scale applications, these best practices are essential. For example, in an enterprise CRM system, applying DRY and separation of concerns can prevent code duplication across modules like customer management and sales analytics. It makes future updates much more manageable. We studied design principles like solid and methodologies such as domain driven design provide the framework for building robust scalable software. When combined with best practices like DRY, KIWS and separation of concern, they help you craft systems that are not only easier to develop and maintain but also adaptable to change. If you found this content video helpful, please hit the like button, subscribe to what you want for more insights on software architecture, and share your thoughts or questions in the comments below. What design architecture do you find most valuable in your projects? In our next video, we will explore cloud and modern architecture. So